Yes, dear students. Now in this video I will derive expression for capacitance of parallel plate capacitor. How the capacity means ability of holding charge depends upon shape and size of capacitor. In our syllabus we have simply parallel plate capacitor. A parallel plate capacitor consists of two metallic plates. These are two metallic plates. Metallic plate, conductor, copper, most probably copper. This is also metal plate, metal plate, and they are kept at certain distance d. When we connect this plate A to source of charge, which is a battery, then some positive charge will appear here, and due to electric induction there will appear negative charge, and since the outside surface earth, so that will go to earth, so net negative charge will induce. I told you in last video, this second plate is brought here to increase the capacitance. So that in figure, these are two plates, not the line actually, like this. In diagram we show these plate by line. इस प्लेट को इस लाइन से दिखाया, इस प्लेट को इस लाइन से दिखाया. These are not line wire, these are plates. Area of each plate A, distance between them D. So figure shows a parallel plate capacitor. This much you can write in the exam. Parallel plate capacitor. The area of each plate, each plate is capital A, and distance between them is small d. ठीक है भाई? When we give positive charge plus Q charge to plate A minus Q charge appears if plus Q charge is on plate A, then due to electric induction, minus Q charge appears on other plate due to earthing, and in between the space between the two plates is either vacuum or filled with air or some dielectric constant. Here the space between the plates is empty, or it may have air also, because at low voltage air also insulator, but which this charge does not flow. Minus Q charge is induced, remember it. In capacitor, the space between the plate either vacuum or filled with some insulating material. We will discuss later on. Now we know charge divided by area gives charge density, and we have discussed while studying Gauss theorem, if two plates have equal and opposite charges, then there exists an electric field in the space between the plates while no electric field outside. Because of superposition they cancel each other, and this electric field between the plate, how much? And this field, the electric field, between the plates is equal to Q upon epsilon 0A. There in Gauss theorem we have learned it is sigma upon epsilon 0. Electric field between plate of sigma is equal to Q upon A. Here I have shown this field by parallel field lines which are equidistant with uniform field, but outside this curved line, dotted line. Why it is so? Why this curved line shown here? Because this formula is true when point is near the center of the plate. Now we know there is a relation between electric field and potential difference. Potential difference between plates, if capital V be the potential difference between the plates, then V equal to E into D. Potential difference is the amount of work done in carrying unit charge. E is the electric field, means force on unit charge. E distance D move किया negative to positive plate, or V equal to Q upon epsilon 0 A into D. This is the potential difference between plates. While the charge on plate A is Q, and we know the potential of this charge, we are connected to Earth, so zero potential. So potential difference means potential of plate A, this first place, and we know C equal to Q by V. So C equal to Q upon V, QD upon epsilon 0A. So this capacitance, this Q cancel, so C come out to be epsilon 0A upon D. This is the formula for capacitance of parallel plate capacitors having insulation, having vacuum between the plates. Smaller the distance in plate, larger the capacitance. Larger the area, greater the capacitance. Actually, air is filled between here. Generally, we can't create vacuum. So there is limitation of keeping the plates very close. Q. In one video I've seen you have viewed the dielectrics topic very well, and there I told dielectric strength. Dielectric strength means the insulator remains insulator to a certain potential difference or electric field. So beyond the maximum value of electric field which it can tolerate without conducting electricity. तो वो insulation can be broken depending on thickness. I will talk later on. But anyhow, if the space between the plates is filled with some insulating material of dielectric constant K. So then electric field will be there, sigma upon F0 K, and keep on this, and we get then capacitance C dash equal to epsilon 0 K A upon D, means C dash equal to K into C. Capacitance get increased K times. I told you capacitance unit is farad, and farad is very big unit, and I proved that to have capacitor of 1 farad in the form of spherical conductor, we need the radius of 9 to the power 9 meter, which is not possible here. Then how to get capacitor of large capacitance? So we can fill the space between plates. We can fill up the space between plates with a material having large value of K. The dielectrics or insulator are used now in gel form, and in our book there is a note that up to 1 millifarad we have constructed parallel plate capacitor. Otherwise, these capacitors have capacitance of the order of microampere or nanoampere order. So I will take in next video a capacitor, parallel plate capacitor, which is partially filled with dielectric. It is completely filled. If the space between plate is filled with insulator, then capacitor get increased K times. Insulator are those which do not allow the charge to flow, but induction may take place. Induction certainly will take place, whether it is filled or empty or having air between the plates. So this was something about capacitance of parallel plate. Remember, C equal to epsilon 0 upon D. I have noticed students are unable to learn, to cram these things. In the morning I asked my students something which I told yesterday. They could not speak out. Please do practice. Actually there are two things. Sometimes we forget such important thing which we daily use. But the things which keep in practice are not forgotten. Yeah, you never forget your name because you are called many times a day. So keep on revising things. Thank you. We'll see you in next video.